looking at the last section on chapter 1. At the end of last week, I looked at the finite or an ending point. So if I was looking at a series and I had a finite point, okay, in which I would have a finite number for the sum of four points in which my common ratio, actually I can't do this, this is an arithmetic one. Let me do that again. 2, 4, 8, 16, okay, so I have 4 terms and I want to calculate what the sum of it is. All right, so we were given 2 equations in which we could find it. What was the first equation? Sn is equal to what?
2 to the 1 plus n minus 1.
Say it again?
2 to the 1 plus n minus 1 3. That's been bracket.
No, that's for arithmetic series.
Oh, T1.
Yeah.
T1 times RVN minus 1.
That?
No. It's minus is not about the n. It's right.
Hold on a second. There should have been 2 of them, right? Okay, so you got, oh, I see, r to the n is what you're saying, minus 1. Get that, right? And that's over what?
Over
R minus 1. Right, so if I have the 4 terms, which my t to the 1 was 2, my r value is 2 as well, so that's t to the 4, subtract 1, all over, in which in this case it'd be 4 minus, or sorry, it'd be 2 minus, my r is 2, so 2 minus 1 like that, right? So that would give me 2. 2 to the 4th is 16. 16 minus 1 is 15. 15 times 2 is 30. Okay? So that works well if my R, my ratio, okay, is consistently going up and it has a stopping point. I have a finite point. But what happens if I have this? What happens if I have a series in which it goes like this? Okay? So in this case here, first of all, I want to identify this as a geometric series or a geometric or an arithmetic series. Which one is it? Geometric? Why?
Because when you divide, you have to divide and you don't have to subtract.
That's right.
T2.
Yeah, very good. You're absolutely right. Okay? I have a common ratio. I don't have a d value. My r value is 1/2, right? Okay? So if my r value is 1/2, what's going to happen here is this guy is going to keep getting smaller and smaller and smaller. But let's look at the sums of this to begin with. Okay? So the first term sum is actually term 1, which would be 16. What's the sum of the first 2 terms? 24. Sum of the first 3 terms? 28. Let's keep going. First 4 terms? 30. What's the 5th term going to be? Yeah, so it's, the sum of, that's going to be 31 because the 5th term then is 1. And then we go to 1/2 next, right? So s to the 6 is equal to 31.5. 1/4. Now I've got s to the 7 is equal to 31.75. So what do you notice these numbers as I'm going further and further into the sum? But smaller amounts, right? So is there a cap on this? Is there a point or a number that's going to give me a value that I'm going to approach but may never hit? All right? And this is what we refer to as an infinite geometric series. meaning it's going to consistently it's going to keep getting smaller and smaller and smaller, these numbers. And this number is going to gradually get larger, larger, and larger, but to a certain degree. It's going to hit a certain point. So using this value right here, I'm going to try and find a value, a limit, as for the sum of this geometric series. Okay? So here's what I want. The sum of an infinite geometric series. This is the symbol for infinity. The symbol for infinity, right? Okay? So I take my t to the 1 value and I divide it by r minus 1. Now, this is referred to as a converging geometric series because it converges on a numerical value for the sums. So what is that value? Well, 16 over, oh, I might have this, just a second here. Might be 1 minus r, is it? Yeah. Sorry. I got this one the wrong way. Should have been 1 minus r here. Okay. So I have 16 over 1 minus r, which is 1 minus a half, which is 16 over a half, which is equal to 32. So looking at these values right here, does it appear that these values are getting closer and closer to 32?
Yeah.
They are. But they'll never hit it. Okay? But it's called a converging geometric series because the values are going to get closer and closer. They converge on a number. In order for this to be a converging geometric series, your r value has to be between minus 1 and 1. It has to be a fraction, a negative fraction or a positive fraction, in order for it to be a converging geometric series. Okay? So, this is a little bit similar to trig, right? In order for you to have a sine or a cos ratio and get an angle, it has to be between negative 1 and 1. So it's one way of making an analogy that works for both. If your r value is not in that range, it's called a diverging geometric series in which it would have an infinite number. All right? So looking at page 41, they talk about an infinite series, a series with an unlimited or infinite number of terms. I showed you what the infinity symbol is. Infinity, of course, means it has no ending. A partial sum is that s to the n, which is this guy right here. So that's a partial sum for it. But that's for a finite one. This is what we refer to as a partial sum for an infinite geometric series, s to the infinity. Okay? A geometric series that goes on forever. To converge on something means to approach it. An infinite series is convergent if the sequence of partial sums approaches a fixed value. So this values here, these sums are going to approach 32. It's a finite value. If an infinite geometric series is convergent, the value of the common ratio is a proper fraction between minus 1 and 1. To find the sum of an infinite geometric series, use s to the infinity is equal to t to the 1 over 1 minus r. And an infinite series is divergent if the sequence of partial sums does not approach a fixed value. That would mean that you would have a value of 2 as your r, or something greater than 1 or less than negative 1. Okay? So let's look at page 42. Give you another example of it. So my series looks like this. 0.5 minus 1
Plus 2.
plus 2 minus 4
And then another plus sign.
and a plus. Okay. So the first thing that I want to do in these questions of any geometric series question is let's identify what t to the 1 is and let's identify what r is. What is t to the 1? 1/2. What's my R value? Close.
Minus 2.
Yes. R value is -2. To get my R value, I take any of these terms and divide it by the term before it that precedes it. And I'm always going to use the easy ones. All right, makes sense. -1 divided by 1/2 might make a mistake. What's -4 divided by 2? -2. That's it. Okay. Then I'm going to check it. 2 divided by -1, -2. We're good. Okay. So is this going to be a convergent or a divergent? Divergent, right? Because it doesn't fall between -1 and 1. Okay, so then the next part says, decide whether is an infinite geometry is convergent or divergent. State the sum of the series if it exists. So it's divergent. Is there going to be a sum for this series? No. Can't get a sum for it because it continues to get larger and larger and there's no actual sum. Okay, if I put an ending point right here, let's say 16 or -16, I don't know which it would be, then you can find it by using s to the n is equal to t1 r minus r to the n minus 1. You can use that equation there, right? Okay, and that's it. So let's look at the next one then. 12 plus 3 plus 3/4.
Plus 3/16.
3/16. Okay. T to the 1 in this one is 12. My R value is 4. Yeah. That's right. 1/4, 1/4. Good for you. Okay. All right. So is it a divergent or a convergent? Convergent because it's between -1 and 1. So I take my t to the 1, which is 12, over 1 minus 1/4, which equals 12 over 3/4, which is equal to 48 over 3, which I believe is 16.
It's divergent, you don't do anything.
Yeah, you can't get it. You can't get the finite sum of it unless it gives you a final term. If it gives you an ending term, then you can do it.
So if it has the ending term, you just plug it into this.
Into the original one right here. Oops. Into this one. Okay. All right. That's it. That's all that we're looking at today. Let's look, actually, before I do that, let's look at 44 for a second. This is a unique question on page 44. Okay? Apply the sum of an infinite geometric series to express the repeating decimal 2.135 as a fraction. Okay? So 2.135 repeat. Now if I convert this, into a fraction, as opposed to working with, or at least this part of it into a fraction, okay? My starting point is this, 2.1, right? Plus, this right here is 35 over 100, correct? So far we're okay. Then the next 35 in the ratio or in the expression would be what? So this is tenths. Actually, I got this. Actually, should be over 1,000. Hundreds, thousands, 10,000s, 100,000s. So this is 100,000 now. Agreed? And the next one would be over How much is it? 10 million. And we could keep going on with that, right? Because it's a repetitive decimal. All right, so it says after the term 2.1, the series looks like 35 over 1,000, 35 over 100,000, 35 over 10 million, and is geometric width. Okay, so what's t to the 1? So if I just focus on this aspect of the, right here, this has a finite value, obviously, right? It's 2.1, done. But if I just focus on this and work with it, my t to the 1 in this case is 35 over 1,000, right? What's my common ratio? 1 over 100. So is this going to diverge on a value or converge on a value, or is it going to just continue to get larger? What gives it away here?
Smaller decimal places.
So in order for it, so is it convergent or divergent?
Same as the other one. The one we did before. Convergent, is that it?
Convergent. Converge, you know what the word converge means, right? Comes to something. So that's what that is. So it's convergent, right? Diverge means goes out in the way. Convergent means comes to something. So it's a convergent, right? Because it's between -1 and 1. Right? So now what they set up to do is this. So this whole thing can be 2.1 plus s to the infinity for this right here. So what they wanted to do is find out what the exact value is that this is going to converge on. So I've got 2.1, add my t to the 1, which is 35 over 1,000, over 1 over 100. Oh, sorry, 1 minus 1 over 100. Right? Okay, so t to the 1 is this. That's this guy, over 1 minus this. I'm just going to flip to the next screen. So I have t to the 1, t 2.1, sorry, plus 35 over 1,000 times 100 over 99. 1 subtract 1 over 100 is 99 over 100, correct? So I have to multiply by the reciprocal of it. So what am I left with? Those two zeros cancel with that. 2.1 plus 35 over 990. Right? So it wants it as an equivalent fraction to. So I have 2 and 1/10 plus 35 over 990. So that's 21 over 10 plus 35 over 990. Common denominator is 990. So I have to times this by 99 and this by 99. Somebody help me with 21 times 99, please.
2,079.
One more time.
2,079.
2,079 plus 35 all over 990 is equal to 2,100, and that would be 3714 over 990. That is an equivalent fraction to 2.135 repeat.
We really have to do all that.
Absolutely. There's no other reason. Well, they're going to make you do it on question 3. If
Page 47.
All right. So that's that.
Bad.
Okay. Nice.